Hi, advanced students. So we're going to take the concept of significant figures a step further with your class. And if you remember, we did the metric measuring refresher to show you how to measure and to show you that why we need to estimate one place further than our last known mark. So just to refresh here, the numbers reported in a measurement are not limited by the measuring tool, not when you are counting things. Significant figures in a measurement include the known digits plus one estimated digit. Remember, always estimate one place further than what is shown on the scale of the measurement tool. So, counting significant figures. So this is if we have data presented to us. We want to know what digits are important or significant to that measurement. So here's the rule number one. All non-zero digits in a measured number are significant. Only a zero could indicate that rounding occurred. So for example, in this one, 38.15 centimeters, 38.15 centimeters, we have 1, 2, 3, 4 significant figures. And you might be going, well, why do I need to know how to count this? Well, most of the time in science, you're going to be doing some sort of a calculation, whether that's finding the mean of a set of numbers or maybe finding the volume of something, and you're going to be doing a calculation with that, and you need to understand how to just look at data and determine what's significant so that you can do a correct calculation and still continue to speak that language of science. So in this one we have 5.6 feet, two significant figures, 65.6 pounds. So how many significant figures there? Exactly. Oh, I'm a little ahead of myself. Three significant figures. There we go. There it is. Super job. Okay. Next one we have 122.55 meters. So how many here? You are so smart. That is correct. Five significant figures. And we have 8, I'm significant. 0, I'm not. So sometimes 0 is significant, sometimes it's not. Okay? And we'll get to those details coming up. Exception number 1. Zeros are losers and insignificant except when they are between non-zero numbers. Okay? So they cannot be rounded unless they are on the end of a number. So zeros sandwiched in the middle are significant. So this is 50.8 millimeters. It has three significant figures. 2001 minutes, that has four significant figures. Now then I have 0.702 pounds. This one's a little tricky. How many of those are significant? Our little animation there. Yes, that's correct. 3 are significant. This one is just a placeholder. It is not significant. So let's look at our last one here. 0.00405 meters. So let's see if we can figure that one out. And once again, only that sandwiched 0 is significant. I like to think of it as if I were to write this in scientific notation. How would I write it? Well, on this one, I would write, there's my arrow, 7.02 times 10 to the negative 1, okay? So that tells me, wow, I keep losing my arrow. So that kind of helps me figure out, yeah, that one really doesn't matter. And the same here, 4.05 times 10 to the negative 3 meters. That tells me that these are not, I don't need that when I write it in scientific notation. Okay, so that also kind of helps me figure out which ones are significant. So why most other zeros are losers? Most zeros are losers and insignificant, such as, here we go, left side zeros. Left side zeros are not significant. They are only serving as placeholders. So this is rule number 3, and I just went over this basically. So these are just placeholders, and again, going back to scientific notation, those would not be in my number. Okay, so that tells me right off the bat those are not significant, so there's only one here. These two are placeholders, so only these 3 are significant. And see if you can figure that one out. Yes, that's correct. Only 2 of those are significant, the 4 and the 2. And on the last one, good job, only 3 of those are significant, the 2, the 6, and the 2. So why most other zeros are losers? Another reason why zeros are losers and insignificant. Rule number 4, right side zeros in numbers without decimals. Again, without decimals are not significant. They too are only serving as placeholders. So again, in scientific notation, I am not going to put these zeros that are trailing off at the end. Now this one is a little tricky. We'll get there here in a minute. So 25,000, only the 2 and the 5 are significant. 200 people. Now why does that one say 3? It seems to be following this rule, so it seems like it would only be 1. Well, 200 people is not a measurement. Okay? It is a counted number, so all 3 of those are significant figures because that is a counted number, not a measurement. This one, we've got 48,600 gallons. Again, scientific notation 4.86. Okay, times 10 to the 4th. All right, so that one doesn't count. Now this one, it gets pretty tricky here on the last one. We've got 25,005,000 grams. That one's a little tricky. Good job if you got 5. So those sandwich zeros are significant, but the 3 at the end are not. So exception number 2, zeros are losers and insignificant, except, again, rule number 5, right side zeros in numbers with decimals are significant. Right side zeros in numbers with decimals are significant, and that's because it's showing how precise our measurement was, okay, or our measuring instrument. So 2.30, that's telling me that the last known mark on my instrument was at the 10th of an inch. So there we go. So that's one's got 3. This 0 with the decimal is telling me that my last known mark was at the whole foot number. Okay, so 4 significant figures. So I'm significant thanks to my buddy the decimal. This one, all 5, again, are, I keep losing my arrow, sorry kids, are all significant. Okay, so again, my last known mark must have been out to the 1,000th on this gallon. Okay, and the same with my grams. My last known mark must have been to the whole gram because I'm estimating out to the 10th, so all 6 of those are significant. So the simplified rules, all regular numbers are cool, zeros are losers, not significant, except if the 0, is surrounded by cool numbers anywhere to the left and right, or if the 0 is on the right side of a cool number and there's a really cool decimal present. So here's our learning check. Which answers contain 3 significant figures? That's correct. Choice 2 and choice 3 contain 3 significant figures. We have a decimal here, which makes that one significant, so this one has 4. And these are either left side zeros or right side zeros. It says all the zeros are significant in which one? Or which ones? That's correct, 2 and 3 again. So we have right side zeros with a decimal. And then we also again have a sandwich 0 and a right side 0 with a decimal. So 534,675 rounded to 3 significant figures is, that's correct, 2 or 3, again, because these 3 zeros are not significant and the question asks for significant figures. So 535,000 or 5.35 times 10 to the fifth. It says, in which sets do both numbers contain the same number of significant figures? So on this one, all of these are not significant, so we just have 2, and all of these are not significant, so we just have 2. This one has a decimal, which makes all of the zeros in here significant. And we also have decimals in this one with our right side zeros, which makes them significant as well. State the number of significant figures in each of the following. We have 0.030 meters, so we have a decimal. But these are left side zeros. This is a right side 0 with a decimal, so those two are significant. On B, all 4 are significant. We have a sandwich 0 and we have a right side 0 with a decimal. On C, that's correct, only 1, because all of those are left side zeros. On D, all 3 are significant because we have right side zeros with a decimal. And this one's kind of tricky. On E, look at what we're looking at here. So if you guess 7, that's correct because that is a counted number, not a measurement. Now then, you might want to stop here for a minute because this is a lot of information to take in, and just take a break, okay? Because what we're going to start with next is adding, subtracting, and multiplying and dividing with significant figures. And it's you know, the rules are, it's just really learning the rules and applying them. I don't mean to scare you. So if you need to take a break for a minute, you can. So rounding rules with adding and subtracting. The theme here is that you're only as strong as your weakest link. Okay, so when we're adding and subtracting, we look at the number that's going into our calculation with the least number of decimal places, and that's how we decide how far out we are going to round, okay, or go to with our decimal places. So we have 25.2, 1 decimal place, 1.34, 2 decimal places, so we end up with 26.54, but we're going to write our final answer as 26.5 because we're not going to count in that 4 because this measurement obviously was not that precise. So we really can't go out further than that. Now we can use the 4 to round, but we're not going to write that in our final answer. So we only go out 1 decimal place on that. Okay, so learning check. In each calculation, round the answers to the correct number of significant figures. Now this is pretty simple because if you know the rule, you can figure it out. All right, you don't even have to use a calculator since this is multiple choice. So we've got 2 decimal places, 1 decimal place, 1 decimal place. So that means that our final answer is going to go out, that's right, 1 decimal place. Same thing here, 3 decimal places, 1 decimal place. So this has to be our final answer because it only goes out 1 decimal place. So that's not too difficult. So now multiplying and dividing. Again, you're only as strong as your weakest link, so we round or add zeros to the calculated answer until we have the same number of significant figures as the measurement with the fewest significant figures. Okay, so I'm going to look at these two numbers and I'm going to see this one has 6 significant figures. This one has 4. So my final answer has to have 4 even though my calculator shows 2.2245047. Okay, I'm going to scale it back to only 4 significant figures. Okay, 6 sig figs, 4 sig figs, that's the weakest link. So our final answer has 4 sig figs. Okay, so again, just by using logic, what's our lowest number of significant figures? 2. So that means even without doing calculations, our final answer is going to have 2 significant figures. Okay, now this one goes back to just knowing the rules. This one has 4 significant figures, and how many does this one have? And this one gets a little tricky. Okay, our final answer is 60. This has 1 significant figure, but remember we either need to round or add zeros so that we get there. Alright, so our final answer probably shows something like this, but we can only show 1 significant figure. So that means that we have to round back to 60. Okay, this 0 is not significant. Okay, so now we've got 2.54 times 0.0028. Okay, keeping track of your sig figs here. 0.105 times 0.060. So it looks like we've got 3 sig figs, 2 sig figs, 3 sig figs because of the sandwiched one, and 2 here. So that means that our final answer is going to be 11. All right, same thing here. 2, 4. Our calculator shows this 7,299.8, but I've got to scale that back to 2. So I've got to round to 2 significant figures. So that means my final answer is going to be 7,300. Okay, again, you can use those as rounders, but they can't show up in your final answer. Okay, next one. So it looks like we've got 4 significant figures, and it looks like we've got 3. My calculator shows 0.03816. So that means my final answer has to round out to 3 significant figures. I'm going to use that 6 as a rounder, and so I'm going to end up with 0.0382 as my final answer. And that's it. Thank you for watching.